For the last year or so, my dad's weapon of choice for the single track has been his 2013 Scott Scale Superlight. With Stan's Valor wheels, a RockShox Sid up front, and carbon galore, this monster weighed in at 19 pounds and 10 ounces. As light as it was fast, it had one caveat. It was set up with a 1x10 drivetrain. Looking to make this an even better and more versatile bike, Dad started getting the idea of upgrading to an 11-speed drivetrain, and he even started exploring the new SRAM Eagle 12-speed drivetrains, though there was one hurdle that he had to cross. His wheels have a standard Shimano freehub and not an XD hub setup for the larger cassette ranges. Undeterred, he found a slew of parts and discovered a way to convert a Shimano SRAM 10-speed hub to a 1x12 Eagle drivetrain. The first part needed in this conversion was a new shifter. As I said before, the SRAM GX Eagle 12-speed shifter was the choice that he went with. This is easily swapped out for a higher-end SRAM shifter, but as long as it is 12-speed, it'll work just fine. Next up, we have the SRAM Eagle 12-speed rear derailleur. Again, this is interchangeable, but I have to say that the GX derailleur is one of the baddest looking derailleurs I have ever seen. It features a narrow, wide pulley system, as well as a lightweight but robust design. It's going to be able to withstand some hits, while also keeping the back of your bike light. The final piece of the puzzle from SRAM is the 12-speed chain. There isn't really anything special to say here, other than the chain itself is designed to work optimally with SRAM components, and the GX version of the chain is pretty affordable as well as light. Last but not least, we have the part that makes this conversion possible. The Sunrace CS-MX-80 11 to 52 tooth 12-speed cassette. It's made to mount to Shimano hubs using the spaces on the free hub itself. With all the parts lined up and shown, it's time for a weigh-in. These items don't exactly weigh a ton, and the form factor on them is perfect. The difference in the sizes of the cassettes was astounding. The cassette was almost bigger than the brake rotor that Dad had on his rear wheel. The first step in replacing any drivetrain is removing the cassette that is currently installed on the bike. To do so, 3 tools will be needed. A cassette tool that will fit your cassette, which can be found easily with a Google search, a chain whip, and a leverage tool for the cassette tool. Rotating the cassette tool counterclockwise while holding the cassette in place with the chain whip will break the cassette loose, allowing us to remove it. Take note that if there is a spacer on the bottom of your cassette, you will need to remove it for the spacing of the 12-speed cassette to work. Next, apply a thin coating of grease on your free hub to allow an easy installation and to cut down on metal contact and/or friction. Looking through the cassette, you can now line up the cutouts in the center of the cassette with the prongs on the free hub. They should line up like a puzzle and easily slide on. The cassette is normally shipped the way that it should be placed, with spacers for certain cogs going into the space that they belong. The lock ring will go on if you place it correctly. Dad and I finally got it to thread on just right. Once you get it hand tight, you can use the tool you're using for leverage to torque the lock ring down. There are some distinct clicks when tightening it down, and once you feel or hear those, normally that's a good tension. You can always check the torque specifications if you have those tools handy. With the cassette on and the wheel mounted, we move to the front of the bike to work with the shifter. Once your grip, brake lever, and old shifter are removed, you can slide the new shifter into place. Once it's on the bars, before tightening it down, I normally run the new cable through the housing to ensure it is long enough and that I don't have too much or too little slack where I'm going to bolt it down. Note that if you were wanting to, this is a great opportunity to replace the housing on your bike. Dad's was practically new, so we just reused his. Once the cable has been ran through, you can mount the brake and grip back onto the handlebars and place the shifter and brake where you prefer it. Be careful not to over-tighten, as it could damage your handlebars. We use a 5 Nm torque wrench to ensure proper torque is applied. Next, we mount the new derailleur. Each derailleur will thread on and off with the bolt that you can see being tightened here. This bolt threads into your derailleur hanger. Pay close attention to the lip found near the back of the screw, as that has to rest on top of the derailleur hanger for proper shifting. It's easy to lose track of that and have it slide in underneath the derailleur hanger, which can cause some headaches. If you've ever heard the expression threading a needle, the same concept applies here. Once the derailleur is mounted, you can thread the shifter cable through the necessary path that will allow us to shift. It takes some playing and some trial and error, but the path for the cable is normally easy to follow. It may involve some head twisting, but once you get it, you can see how mainstream the cable looks in the derailleur. Now we have to fit the chain to the gear ratio on Dad's bike. What he is doing is a method to cut the chain to the right length. Pulling the chain together can show where the links meet up, and then you can add or subtract a link depending on the chain and the gear ratio. A chain tool is needed to break the link out of the chain and to allow for the addition of the master link. The master link slides in together and will lock into place once pressure is applied. Sometimes it's possible to lock it together by pulling on it, but oftentimes you will have to apply more force. A common method for doing this is sitting the bike on the floor or leaving it in the stand and holding the rear brake and giving the crank one hard pedal to pull the chain together. Now that we have the chain and cable in place, it's time for alignment of the derailleur. The first thing that we adjust is the B-screw, which adjusts the openness of the derailleur. SRAM actually provides you with an alignment tool with the new derailleur. Get the cogs to match the cutouts on the alignment tool, and that should be the perfect placement for the B-screw. Once you're at this point, you're pretty much in the home stretch. Now there's just some basic adjustments to make before you're ready to take the bike on the trail. Adjust the cable tension, play with the shifting, adjust the tension again, so on and so forth. Once you have everything in place and everything is aligned and tightened, you can get some crispy, smooth shifting from this drivetrain. Everything works together as it should, and the bike is now a 1x12 bike. All in all, this entire project took us about an hour. An upgrade that we previously thought was reserved for fancy XD hubs was now applied to my dad's lightweight hardtail. I will leave a link in the description to all the parts used for this conversion. Maybe your drivetrain is due for an upgrade? Thanks for watching. Ride safe.